Welcome to another episode of Terry's Notes, and today we are going to be looking at the January 2016 paper number 5. Okay, so in the diagram below, not drawn to scale, we have ST, which is 6 cm. We have WR, which is 6 meters. WR is 11.2 meters. And WT is 14.8 meters, and angle WRS is 90 degrees. Alright, so the first part asks, calculate, given your answer, to one decimal place the length of RS. So we want to measure this length here. Alright, this is RS. Now, if you look at the diagram, we are dealing with a right angle triangle. So we have, and the right angle is here. So what we can do is use Pythagoras Theorem to find this length here, which is RT. So we can find this length here, and if we find this length, then we just subtract 6 from it and we will get RS. Right? So using Pythagoras Theorem, we know that the theorem is, and this is applied to a right angle triangle, we know that A squared plus B squared is equal to C squared. Alright, where C is a hypotenuse, so it will be 11.2 squared plus RT, which is what we want to find. So plus RT squared is equal to a hypotenuse squared, which is 14.8 squared. So RT squared is equal to, I will not square it as yet, I will put 14.8 squared minus 11.2 squared. So RT squared is equal to, at this point you can use your calculator, so 14.8 squared minus 11.2 squared is equal to 93.6. Now, it is always good to recheck your answer, so let me just double check that. So 14.8 squared minus 11.2 squared is equal to 93.6, right? So RT, will be the square root of 93.6. Right, so RT and this will be 9.67. right, but the question was asking to one decimal place, so I can use 9.7 meters. Right, so that is RT, but we want to get RS. So RS is equal to RT minus ST, which is 9.7 minus 6. Right, that is from the diagram, and that will give us 9 minus, that will be 3.7 meters. Right, so once we have a right angle triangle, we tend to use Pythagoras Theorem if we want to find lengths, provided that we have two sides and we have one side that is unknown. Now the next thing, we want to measure the angle RTW. Where is RTW? RTW. This angle here is RTW. So let's call that theta. Now we are dealing with a right angle triangle here, so we need to know how to label a right angle triangle. This is the angle that we want to know. This side is the opposite. This side is the hypotenuse. Right, the side opposite the right angle is the hypotenuse, and this side here, which is RT, is the adjacent. Right, the reason why I'm labeling it like this is that we need to figure out which trigonometric ratio we're going to use to find the angle. So you may have seen this before. So ka poor, right? So this is just a way to remember the trigonometric ratios. So sine is opposite over hypotenuse, is the first one. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now the thing is, in this question here we have the lengths of all the sides, so we can use any one of the trig ratios, but I will just use the one that has opposite over hypotenuse. You can use either and get the same answer. So we have opposite and we have hypotenuse, so therefore we can say that sine theta is equal to opposite over hypotenuse. So sine theta is equal to opposite, which is 11.2, and the hypotenuse is 14.8. So therefore sine theta is equal to 11.2 divided by 14.8, which is equal to 0.757, right? So therefore theta is equal to sine inverse of 0.757. Therefore theta is equal to second function sine 49.2 degrees. So this is 49.2 degrees. Now remember, I said you can use any one of the trig ratios here because we have all the sides. So let's just try it with another one. Let's use cosine. So cos theta is, based on our acronym here, it's adjacent over hypotenuse, right? So cos theta, the adjacent length here is RT. We worked out RT and we got 9.7, right? Over the hypotenuse, which is WT, which is 14.8. So therefore cos theta is equal to 9.7 over 14.8. 9.7 divided by 14.8, and we get 0.655. So 0.655. Therefore theta is equal to second function cos 0.655. Therefore theta is equal to second function cos, we get 49.0. Right, so approximately the same thing. The reason why we got a difference in answer is that for the adjacent we had rounded it to 1 decimal point. Right, so we can use sine or cosine and we get the same answer. Right, so let's move on to the next part. Alright, so the diagram below shows triangle ABC and its image A prime, B prime, C prime after undergoing a single transformation. Alright, so part 1, what are the coordinates of triangle A, B and C? So just read this directly from the graph. So we have A, which is 3, 2. B, coordinates of B, that is 6, 2. And the coordinates of C, that is 3, 4. Now all I'm doing is reading off the coordinates from the graph. So like A, the first value is the X value, so it's 3 going up here and 2 across. That's how I got 3, 2. Now we're looking at the image after the transformation. So A prime, we're reading off these values here. It's 2 minus 3. B prime is 2 minus 6. And C prime is 4 minus 3. 4 minus 3. Right. Now we have to describe fully the transformation that maps triangle ABC onto triangle A prime, B prime, C prime. Alright. Now I did this question on an actual graph paper using a pair of compasses. So if we look at ABC and its image, realize that's not enlarged, so it's not an enlargement. it's not a reflection, right? So my next guess would have been a rotation. Now, if you think it's a rotation, then it must be rotated about some point. Let's look at A. If we draw a line, let's say we assume the center of rotation is the origin. If we draw a line from 0, 0 to A, and then a line from 0, 0 to A prime, right? If we take our compass and we put it at this point here, and we make an arc, right? We are going to realize that it is a rotation about the origin, right? So one easy way to check this is to take our compass, put one end of the compass at 0, 0, connect it to A, and move the compass. It'll pass through A prime. We do the same thing for B. We draw a line from the origin to B, and we rotate it again to see if it passes through B, right? So describe the transformation as fully as you can, right? So usually we need to give the center of rotation. So we're saying it's a rotation, right? And what angle? We need to give the angle of rotation. If we measure the angle here, this angle here, right? This will be, so it's a rotation of 90 degrees, and we're going from A to A prime, so we're going clockwise, 90 degrees clockwise, right? About, we need to give the center of rotation about the point 0, 0, right? So usually if we have to describe our transformation fully, we need to give certain pieces of information. So it's a rotation, we need to give the angle and the direction, 90 degrees clockwise, and we need to give the point about which we are rotating. In this case, it's the origin, which is 0, 0, right? So using our compasses, we can easily check to see if it's a rotation, and we can use our protractor to measure the angle. It was measured and I got 90 degrees. Right, now in part 4, they said on the same graph, we draw the line x equal 1. Okay, let me see how I'm gonna do this. So the line x equal 1, where is that? Right. So we need to draw a vertical line coming on here. Right. So the line x equal 1 would be this line here, right? This is the line x equal 1, and the triangle, we want to draw this triangle here, A double prime, B double prime, C double prime, the image of triangle ABC after reflection, right? So we are taking this triangle here and reflecting it in the line x equal 1. When we are doing a reflection, so we have C here, so therefore it must be an equal distance behind the mirror line. So therefore this here, this point is C double prime. A will be this point here, and B, if we look at B is 1, 2, 3, 4, 5 cm in front of the line, so therefore it will be 1, 2, 3, 4, 5. So this will be B triple prime, right? So our triangle in this case would be here, right? And so therefore this image here is a reflection of this triangle in the line x equal 1. Okay. The key thing to remember is that the distance in front of the mirror line is the same distance behind the mirror line. So that is how I was able to determine the coordinates of the new triangle. And then the last part said one geometrical relationship between triangle ABC, triangle A prime, B prime, C prime, and triangle A double prime, B double prime, C double prime. Right? If we look at all these triangles, we realize that they all have the same length. They have the same lengths. The angles are the same. So therefore, we say that all three triangles are congruent. Right? So they're all congruent triangles. Okay, and that's it for question 5.